Welcome back. This is N1IR, and we're going to continue on. So the percentage of power loss that would result from a transmission line loss of 1 dB would be approximately 20.5%. The ratio of peak envelope power to the average power of an unmodulated carrier is 1. All right, so we want to find voltage in this question. 245 volts would be the voltage across the 50 ohm dummy load dissipating 1200 watts. So again, there's a couple ways to do this. Here you can find the magic circle, and we know E is the square root of P times R. So let's do that first. So E is equal to the square root of P times R. All right, so that equals P, power, was 1200 watts, times R. R was 50 ohms. Let's extend that out a little bit. All right, so on a calculator, we want to type in 1200 watts times 50 ohms, and then second function square root of the answer. Okay, that's 200 equals 244.9 volts. All right, did everyone see that? So I did 1200 watts times 50. That gave me an answer of 60 to the third. Okay, I take my square root of the answer I just got. That gives me 244. Okay, so okay, next one. 1060 watts is the PEP of an unmodulated carrier with an average reading of the watt meter connected to a transmitter output indicated 1060 watts. All right, so this again goes back to it's an unmodulated carrier. So if we go back to this one, the ratio of peak envelope power to average power is 1. So peak envelope power of an unmodulated carrier, a ratio of 1 gives us 1060. All right, 625 watts is the output PEP from a transmitter if an oscilloscope measures 500 volts peak to peak across resistor, 50 ohm resistor connected to the transmitter output. All right, so what are they asking? They're asking for power. They're asking for power, and they're giving us 500 volts peak to peak, and they're giving us resistance, which is 50 ohms. So this is the given. All right, so again, we have to convert that peak to peak to RMS. So we're looking for power. So peak to peak, right? So 500 divided by 2, that equals 250. So peak to peak, we divide it by 2, gives us 250 volts peak. Okay, peak to RMS, 250 volts peak times, remember, 0.707. Okay, so that's 250 volts peak times 0.707. This gives us an RMS value of 176 volts RMS. Okay, now we can find our power. Remember our magic circle, P, I, E. There we go. So it's the same thing over and over again. You're just plugging in the numbers. As long as you know the process, right? You got to convert peak to peak, and then convert that to RMS. Okay, and then it becomes really easy. 176 volts, right? And we want to find power. So power is current times voltage. So again, we don't know the current, so we can figure out the current, I. Remember our other magic circle, EIR. Okay, so E, which we know, divided by R, which we know. So that's 176 volts over R, which is 50 ohms. Again, this is an additional step. If you remember, if you do a route memorization of the Ohm's law chart, you can easily see power, and we have voltage, and we have resistance. So power is equal to E squared over R. But let's say we don't memorize that. We memorize our two magic circles. We just need that additional step in there, and then we don't have to memorize a lot more things. Right? So 176 volts divided by 50. Of course, that's a little bit different. I do it a little bit different than what's in the book. Right? So that's 3.52 amps.